First problem, verify the initial value theorem. IVT means initial value theorem for the function f of t equal to a e power minus bt. A e power minus bt. A e power minus bt. Okay. So what is the initial value theorem? Write the solution for this. The initial value theorem is, what is the initial value theorem? Limit t tends to 0 f of t equal to limit s tends to infinity s into f of s. So first we take that LHS. What is f of t here? A e power minus bt. Then limit t tends to 0 f of t equal to limit t tends to 0 a e power minus bt. So that is a into e power 0 is a. RHS. RHS. RHS is, first we have to find f of s. So what is f of s? L of f of t. So what is L of f of t? L of a into e power minus bt. So a into 1 by s plus p. A into 1 by s plus p. What is s into f of s? S into f of s. S into f of s equal to s into a into 1 by s plus p. That is as by, take it as outside, 1 plus b by s. Cancel this. You take that limit s tends to infinity. S into f of s, that is equal to limit s tends to infinity. SS get cancelled, not A. A will be there. SS get cancelled. A divided by 1 plus B by S. So A divided by 1 plus B by infinity 0. Therefore it is A. LHS equal to RHS. Answer verified initial value theorem. Hence verified initial value theorem. Second problem, verify the initial value theorem for the function f of x equal to e power minus 2t sin. Verify the initial value theorem for the function f of t, not f of x, f of t equal to e power minus 2t sin t. So here, what is the initial value theorem? Limit t tends to 0 f of t equal to limit s tends to infinity s into f of s. So what is f of s here? So first we take the LHS. LHS is e power minus 2t sine. So limit t tends to 0, e power minus 2t sine t equal to 0. What is f of s for RHS? What is f of s here? F of s equal to 1 by Laplace inverse of, Laplace transform of e power minus 2t sine. So that is 1 by 1 plus s square, where s tends to s plus 2. That is 1 by 1 plus s plus 2 whole square. S into f of s. What is s into f of s here? Taking that limit s tends to infinity, s into f of s. If we expand this, limit s tends to infinity, s into f of s, that is equal to limit s tends to infinity, s into f of s. F of s is 1 by s square s plus 2 na, plus 4s plus 4 plus 1 plus 5. So s tends to infinity means infinity by infinity in determinant form. Therefore, you will get that limit s tends to infinity 1 by 2s plus 4. So when s tends to infinity, 1 by infinity, that is equal to 0. That is LHS equal to RHS. Hence, verified initial value theorem. Third problem. Verify the initial value theorem for the function f of x equal to, verify the initial value theorem for the function f of x equal to 1 plus e power minus t plus t square. Verify the initial value theorem for the function f of x equal to 1 plus e power minus t plus t square. So here the initial value theorem is limit t tends to 0 f of t, the limit s tends to infinity s into f of s. So what is f of x here? Not f of x, f of t. Limit t tends to 0 LHS limit t tends to 0, f of t equal to limit t tends to 0, f of t is 1 plus e power minus t plus t square. So 1 plus 1, 2. Now come to RHS. Let we have to find f of s. F of s is Laplace transform of f of t. So that is Laplace transform. What is f of t here? 1 plus e power minus t plus t square. So 1 by s plus 1 by 1 plus s or s plus 1. 1 by s plus 1 plus 2 by s cube. But what is RHS here? RHS is limit s tends to infinity s into f of s. So limit s tends to infinity s into f of s is s into 1 by s plus 1 by s plus 1 plus 2 by s cube. Therefore, that is limit s tends to infinity s by s plus s by s plus 1 plus 2s by s cube. So what happened? SS get cancelled. Here also s get cancelled. Then this can be written as 1 plus 1 by s. Therefore, when limit s tends to infinity, 1 plus 1 plus 0. So RHS is initial value theorem verified. Am I audible?
Yes, sir.
Next one is final value theorem. Final value theorem. Statement. The Laplace transform of f of t dash of t exists and L of f of t equal to f of s. L of f of t equal to f of s. Then then limit then limit t tends to infinity f of t equal to limit t tends to infinity f of t equal to limit s tends to 0 limit s tends to 0 s into f of s. How to prove this? By the formula L of f dash of t equal to s into L of f of t minus f of 0 is the proof. Limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. So how can you easily identify or easily remember that initial value theorem and final value theorem? Initial value theorem means t tends to 0, but the right hand side and left hand side will not change. The left hand side and right hand side will not change. For that final value theorem, it tends to infinity. So when that it is t tends to 0, here s tends to infinity. If it is t tends to infinity, s tends to 0. So here L of f dash of t equal to s into L of f of t minus f of 0. But L of f of t is integral over 0 to infinity e power minus st f of t dt, that is equal to s into L of f of t minus f of 0. Take limit s tends to 0 on both sides. Take limit s tends to 0 on both sides. When you're taking the limit s tends to 0 on both sides, what happens? Here, both the sides you can write that limit s tends to 0, limit s tends to 0, integral over 0 to infinity e power minus st f dash of t dt, that is equal to limit s tends to 0 s into L of f of t, that means s into f of s minus f of 0 minus f of 0. Now integral over 0 to infinity, taking that limit s tends to 0 here, e power 0 is 1 f dash of t dt equal s tends to 0 means that is f of 0 only. Am I audible?
Yes, sir.
Fine. So here 0 to infinity f dash of t dt equal to limit s tends to 0. See, even that s tends to 0 or s tends to infinity, the value will not change because it is not connected with that s. It is f of 0 only. So s into f of s minus f of 0, or to write. Limit s tends to s tends to 0, or to write. Limit s tends to 0, to write. What is f dash of t dt? F of t. Integration of f dash of t is f of t for 0 to infinity. That is equal to limit s tends to 0, s into f of s minus f of 0. Substituting infinity here, f of infinity minus f of 0, limit s tends to 0, s into f of s minus f of 0. That f of 0 get cancelled, but that f of infinity can be written as limit t tends to infinity f of t, that is equal to limit s tends to 0, s into f of s. Hence proved final value theorem. Hence proved the final value theorem. Problem number 1. Verify the final value theorem for the function f of t equal to t square e power minus 3t. T square e power minus 3t. Write the solution here. But limit t tends to infinity, the final value theorem is limit t tends to infinity f of t equal to limit s tends to 0, s into f of s. If you are taking that limit t tends to infinity, what happens? That is f of t equal to t square e power minus 3t. So t square e power minus 3t. So if you write the t square by e power 3t, e power, first of all, e power minus infinity 0. So if you are substituting that limit t tends to infinity, limit t tends to infinity. So here also you have to write that limit t tends to infinity f of t equal to limit t tends to infinity t square e power minus 3t. So e power minus infinity, that is equal to 0, therefore this value equal to 0, because any value multiple with 0 is 0 only. Add RHS, this LHS, na? LHS is 0. Come to RHS. For RHS, first you have to find f of s. F of s is L of f of t. So what is L of f of t here? L of f of t is t square e power minus 3. T square e power minus 3t. So that is equal to 1 by 2 by s cube, where s tends to s plus 3. So 2 by s plus 3 whole cube. Therefore, limit t tends to, sorry, s tends to 0, limit s tends to 0, 2s divided by s plus 3 whole cube, na? 2s divided by s plus 3 whole cube, that is equal to 0. Because if you are substituting that s here, 0 by 9, so that is 0. It is RHS. Hence verified. Hence verified. Final value theorem. Problem number 2. Verify the final value theorem for the function. Verify the final value theorem for the function f of t equal to minus e power minus c. So what is the final value theorem here? Limit t tends to infinity, f of t equal to limit s tends to 0, s into f of s. Taking the LHS here, limit t tends to infinity, f of t equal to limit t tends to infinity. F of t is 1 minus e power minus t. So that is 1 minus e power minus infinity that is equal to 1. This LHS value. For RHS, first you have to find f of s, that is L of f of t. So what is L of f of t? 1 minus e power minus t. 1 minus e power minus t. Limit. Okay, we have to find this now. So 1 is 1 by s minus 1 by s plus 1. Is it not? So s into s plus 1 here, s plus 1 minus s. S cancel 1 by s into s plus 1. Therefore, limit s tends to 0, s by s into s plus 1. That s get cancelled. Substituting s equal to 0 here, that value is 1. Therefore, LHS equal to RHS. Hence, final value theorem verified. Hence, final value theorem verified. Okay. One problem for practice. Verify initial and final value theorem. One problem for practice. Verify the initial and final value theorem for the function f of t equal to 1 plus e power minus t sin t plus cos t. F of t equal to 1 plus e power minus t sin t plus cos t. Stop the recording.